So in this video we are going to solve this undirected graph cycle problem, which is one of Gigs for Geeks. So problem said that given a undirected graph, what is this undirected graph? That means the direction is not specified, like A to B or B to A, both can be possible. So given an undirected graph with V vertices and E edges represented as a 2D vector edges, and here edges of I equals to like U and U to V. Okay, and we have to determine whether the graph contains a cycle or not. Fine. So let's check this first test case. So here we can see that after connecting these edges, we can see that 0 1 2 it is like a cycle. It is cycle. And for the second test case, we can see that it is not forming any cycle. So what this cycle is, we start from 0 and then we end with the 0, so that means it is forming a cycle. Fine. Okay, so for this question, both approach came to my mind at the first time. So can we use here Kruskal algorithm? Like Kruskal algorithm is used to find the minimum spanning tree, but here we can also apply that algorithm. Let's take this example, first one. So 0 to 1, then if we connect this 0 to 1 like this, so here the parent of, at initial level the parent of 1 was 1, at initial level parent of 0 was 0, but here the parent are not equal, so we will join them, and here the parent will be 0, parent of 1 will be 0 and parent of 0 will be 0 only. Fine. And for what will be the second one, like 0 to 2, so if we connect this 0 to 2, so here also we will check first this parent of 0 is 0 and then parent of 2 is 2, so these both are different, so we will join them, and then the parent of 2 will become 0. Fine. And if we join this 1 and 2, so then we will see that parent of 1 is 0 and then parent of 2 is 0. So here we can see that parent of 1 and 2 are same, that means they both have joined, their parent have joined together already. So here we can see that this is forming a cycle. So if we found any such type of thing, then we will simply return true. Okay, so how we can code this? So first I will create one parent array which will be list of range of v, and then also I will create one rank to v. So what this rank is used, it is used for counting the nodes under that parent. Then I will traverse on the edges. Now I will calculate the pair of I equals to get parent of parent comma I, and same with the j. So here I will check if pair of I equals to pair of j, that means it is creating a cycle, so I will simply return true. Else if this pair of I and pair of j are not equal, then I will union them, I will join these two vertices I and j. So first I will check whether the rank of pair of I is greater than rank of pair of j. Then I will a parent of pair of j equals to pair of I, and then rank of pair of I plus equals to rank of pair of j. Else I will do in the reverse order. So here it will become pair of I and pair of j, pair of I, and then pair of j. So here if a count, here first we will check whether the number of nodes which comes under a parent of I is greater than the number of nodes which comes under a parent of J. That means the density of parent of I is more than the parent of J. So I will join the J into the I, and I will also update the parent of, I will also update the rank after joining. Fine. So here our code is done, but here we have to make this get parent function also. So def get parent and then I. Now first we will check if parent of I is not equal to I. If these are not equal, that means parent of I equals to get parent comma parent of I, and then after that I will return parent of I. So here we are finding the parent of ith node, and this process is a path compression. That means if we found the parent of I, that means we will update all the child node which comes under that parent to that parent of I. So this will optimize the time complexity to find the parent. Let's check. So yes, first test is passed. And what will the time complexity here? Okay, so this code is successfully executed. So what will be the time complexity here? So here it is taking big of n, and for the get parent, so it is a path compression approach. So this path compression approach which is a constant, which takes only constant time only. So the overall time complexity here will be big of n only, and the space complexity is also big of n. Thank you.